Whoa.
Yes.
Any exceptions?
We start with the matrix because the matrix is always a good reference point for everything IT related. All right. Leighton, you're on Slack channel. Can you make sure that people can see that are dialed in here? Tell them we're going to work through some technical difficulties. If they're not here, they're second-class citizens, so oh well. We will try to do our best, but we will cap out with whatever we can do. All right. Thanks everybody for coming out. We have a lighter than usual group, I think, maybe because there's a 3-day weekend coming up, and also I think in the announcement that went out, they put March 16th instead of February 16th. Yeah, someone caught it, and and she sent it to me, and I was like, oh, please correct this. And then they corrected it yesterday, so that may be a factor as well. We have a few people that were asking to tie in online. Hopefully they can see, but I'll start off with the usual, like house cleaning, housekeeping, whatever they see, the business stuff. Again, the backlog is here. We have 48 items, 46 items in the backlog. 2 are in the planning stage. One of them I think was pretty useful or interesting was this diversity in IT. Christine, who's not here, she's actually one of our only female speakers or presenters that we've had in quite a long time. But I was listening to a podcast and it was really bringing home the point. I think they were talking about the Apple Watch, the Apple thing, and they were saying they had the most comprehensive fitness tracker on it, but didn't track women's menstrual cycles. Which is like 50% of the population. That's something that happens to almost, 80% of them. So it's like, if you had some diversity in your dev team or your IT teams, maybe some of these things would get brought up. This also came up in an interview process that we had recently where people were kind of being weeded out because they didn't fit into the personality type, which again, maybe you lose out on good people because of lack of diversity in thinking and that sort of thing as well. We have a few that are assigned. Aaron Reinhardt, he used to work here 10 years ago or so. No, maybe not that long ago. I'm trying to remember how long it's been. It's been a while. But he has a lot of industry contacts for some security stuff. And so we're going to we've been trying to get security people from OneCenter to come in and say, hey, security people, let's talk to the dev people and SA people. That's like seeing Kumbaya and all that sort of stuff. It's been hard getting them in. So we're going to get a series of security people from the outside to come in and say, okay, here's how security and dev are working together in other industries, and here's how we can do some modern security integration, that sort of stuff. The SharePoint presenter, we're trying to reschedule that. There was a conflict in schedules. We had that a little while ago, but we're going to have to try to reschedule that. Ben is ready to go whenever we get him back into schedule for the VR, AR demonstration. And I think he did the last time he did the IoT one. And that was kind of one of our best presentations. It was really good. So when he comes back to talk about VR, that's going to be pretty cool.
Trying to get like building 12 or
yeah, well,
36.
Yeah, so it depends on, like, that's why I press a lot for the RSVPs so I can figure out what room to get. So that I think a couple of times we had people like lined up sitting Indian style on the floor just because I didn't know how many people are going to show up, or we don't have enough pizza, or whatever the case may be. So if you RSVP early, it helps me, because if you RSVP Friday morning, it's kind of hard to change the room and then get everyone notified and that sort of stuff. So the earlier you can RSVP, the better. Even if you're not sure if you're going to come, if you think you're going to come, let me know, and I can schedule the right room for the right time, for the right size. Justin's going to be our speaker today. He's going to speak on microservices, which is pretty cool. I've seen, I think, this presentation before.
Yeah.
At Nation.js. Mm-hmm. Yeah, and it was pretty awesome. That's why I was like, hey, can you come do this thing, please, please. So yeah, you guys will enjoy that. Next week, how many people here are in Cold Fusion? It's a safe place. You can admit it. It's all right. So I do know we have, for a long time, I think the center and maybe the agency, like Cold Fusion was the language you're supposed to use. I think everyone unofficially kind of moved away from it, but there's a lot of Cold Fusion apps. I know of at least 3 teams that are writing in Cold Fusion right now, none of which I think are actually here today. But so we're going to have a Cold Fusion developer advocate, Brad Wood. He's going to come and speak to us about modern development in CodeFusion, like if they're running CodeFusion, continuous integration and containers and all that sort of stuff, which I didn't think it was possible, but I guess it is. And we also have the containers and Kubernetes talk that we're scheduling. That's the one I thought Joe was talking about when he said TBD. That one's going to be pretty cool because I think we're going to have talking to Kelsey Hightower, and he's thinking about coming in. So if you're so if you're in the container space, you know how big a deal that is. Like I was like giddy.
That's a big deal.
Yeah, that's pretty big. So definitely RSVP for that one, so we can make sure we get the right space. But there's other. Aaron also knows a few people that I think name-wise, I don't just like drop names, but they're pretty big in the industry as well, in the DevOps and IT and security area as well. So without further ado, one last thing. I say this all the time, but just for the sake of the new people and just for repetition, you do not have to be an expert to present. You want to present on something small that you think is small and it's like 5 or 10 minutes, just let me know. We'll schedule it in. When we first started off, I gave like 80 or 90% of the talks, and I was not an expert in probably none of them, actually. But it's a good way of kind of forcing yourself to learn a new thing. Chances are, if you're up in the front of the room and you're presenting on it, then you probably know more about it than most of the people in the room. And every time that has not been the case, the people that did know more, they're not heckling you or putting you down or anything like that. They usually kind of just, help out where as needed. So everyone learns, everyone benefits from that. So don't be shy. A big part of kind of growing in the dev area possibly is getting up in front of people and explaining things. It can really boost your career as well. All right. So without further,
I was going to say maybe we should just schedule one and let people see what people are willing to do.
So he's saying I should just pick random names and schedule for a
No.
talk. I like that idea.
Take one meeting, take one meeting and just say.
Just lightning talks.
Lightning talks.
Yeah, we did that a little
That's a good
while
idea.
ago, and I think it worked out pretty well. And I think sometimes if a speaker falls off and we have like this informal discussion, those have been pretty good as well. But yeah, let's do the lightning talk, a specific session to do lightning talks where we only have like 5 or 10 minutes per speaker. And that way, you're not going to be the only one that's getting up there for the first time. You can kind of mix into the crowd, right? So that's it for me. I'm going to pass the screen over to Justin. We're going to try to do something where we point my screen at the main screen. Hopefully that works out for those that are online. Let's see. Let's see if this works.
Maybe a little bit close.
A little bit too close?
Yeah.
All right, we'll work it out.
Let's go.
Maybe something. Huh?
Maybe it's
Justin in it too as well. Oh yeah.
There we go.
That works. Good enough for government work.
When you see it in the actual screen, it's
Is that good? You guys can put you all to sleep here? Is that going to be okay? I know it's Friday before a long weekend.
It's
so.
nap time. All right. Cool.
All right. Sorry, I don't want to waste sleep with you over there. Thank you, Andre. Thank you, everyone, for being here, for having me on this campus. It's my first time at Goddard Space Flight Center. It's a really cool space. It's a lot bigger than I thought it was going to be. So I'm looking forward to spending some more time exploring it. But yeah, really glad to be here and have the opportunity to speak to you all. So as Andre said, my name is Justin Bachorik, and I am a software engineer at Capital One. Before I was at Capital One, I worked at National Public Radio, and I was a full-stack developer there. So I was the lead developer for NPR.org, and I was also working on APIs and microservices and things like that. And today I'm here specifically to talk about microservices. So just by way of background, Capital One as a company is an enthusiastic adopter of microservice architecture. We're already running hundreds of microservices in production, and we have a lot of strong executive support to continue this initiative. So it's really pervading everything the company does. It's leading to a lot of cool results. But right now, I'm leading a technical team that's building a new platform that's built on microservices from the ground up, which is kind of an unusual approach, and I'll be happy to answer any questions you might have about that as we go here. So, okay, cool. Let's talk about microservices. We're going to all get on the same page and actually have some sort of shared understanding of what we mean. We should figure out what this term actually means to all of us. But sometimes I find that it's actually easier to answer that question or something, but for dogs. So let's call it dog pool. I don't know. That'll do for now. So awesome. We have this client app we've built, and maybe it's built in like React or Vue or Angular, or maybe it's a native app or something like that. But that's not really what we're here to talk about today. What we're here to talk about is the fact that this app is going to have some sort of backend supporting it, right? We have all kinds of data about dogs and users and schedules and business logic, and we need to have some means of actually making all that possible. But what's that going to look like? So everyone likes JavaScript, right? It's sort of eating the world. So let's say we're going to build our backend stack using Node.js. And we'll use Express as our web framework because it's pretty mature. It's reasonably well understood. There's not a lot of surprises there. People are generally pretty familiar with it. And as I just alluded to, we're going to need some sort of relational database to actually store all this data about users and their dogs and their schedules. So let's pick Postgres, right? Seems like it'll be a pretty good fit. And we're probably going to be concerned about the performance of our application. We want to make sure everything runs really fast. Probably is going to need some sort of caching layers so that these requests can be returned quickly. So let's use Redis for that. And maybe there's some more advanced use cases that involve asynchronous messaging or batch processing or queuing or something. So let's put Kafka in the mix. So this is our stack. And it looks pretty good. We take this, and we start building on it, and it's fantastic. Turns out everybody loves dog pool. They just can't get enough of walking other people's dogs. Who knew? But everybody loves us. The tech industry can't stop writing about us, and we've totally got a winner on our hands. And as this is going on, we start hiring new employees. We start branching out into other markets. Maybe we start powering cat cafes, if you're familiar with those, or bird rentals, or who knows. There's just an unlimited amount of potential out there for what we can do with this idea. And we also, as we expand, start supporting multiple clients. So we have this JavaScript app that we started with, but maybe now we have an iPad app as well. And that iPad app is probably going to have a slightly different interaction model than the native app. Excuse me, than the JavaScript app. So we're going to need to maybe tweak the API a little bit so that that app works as expected for users. Maybe we also, as we expand the dog pool presence, start thinking about business partnerships. We develop some sort of enterprise API for harnessing the power of the dog pool platform. Maybe we make it public and we let developers start to use all of our data and services. And this is awesome. This is kind of the success story that everybody dreams of. But as this is going on, something else is happening. This backend that we wrote to fulfill what was originally a fairly simple set of use cases is now growing in responsibilities pretty dramatically. So let's take a look at some of those roles. So we already talked about user management, sign up, sign in, all the user data backing accounts. The backend's keeping track of all of that for us. We have all the inventory of the various pets that are associated with our system. So which users map to which pets and how old they are and what species they are and things like this. We have logic that is concerned with walk scheduling, who gets to walk what animal when. We have a lot of stakeholders, a lot of investors that are concerned with making sure that we're actually delivering on whatever KPIs they care about. So we're going to need some sort of business reporting and some kind of analytics that are built into our backend. We're probably going to have some notifications, right? We need to send emails or SMS or push notifications or whatever to our users. And we have to support these APIs for these client apps that we've been releasing for our users to have fun with. So we have a client app API. And then we probably also have a business app API as well. And now this little Express app that had pretty humble beginnings has grown to millions of lines of code. And there's been a lot of negative knock-on effects of that whole process. So for one, the modular responsibilities are becoming really blurry. It's getting increasingly hard to differentiate between the user management and the walk scheduling portion of the code base. And analytics is kind of all wrapped up in that in some kind of weird way. Deployments are getting a lot thornier as well, because every time you deploy, you're deploying this massive application, and there's a lot of testing that needs to be done to make sure you haven't broken anything since the last time you deployed something. And God help you if you want to write a database migration, because who knows what is using which fields in each of the tables in your Postgres database. But that's not all. In addition to these technical problems, we're finding that hiring engineers is getting a lot harder, because as people come on board, there's a lot more code that they really have to master and internalize in order to get anything productive done. You know, maybe you were the technical co-founder of Dogpool, but you know, you're the only one that really has a full picture of the application in your head, the only one that really understands the code base. Or at least you think you do, until one day you start looking at code that a new engineer wrote, and you realize that nobody actually understands how things work, and that's a scary moment. So as a result of all these factors, Dogpool's ability to compete in the ever-competitive dog-sharing marketplace is quickly dwindling. And this is kind of an unhappy state of affairs. So this is often known as a bloated or unmaintainable monolithic architecture, sometimes colloquially referred to as a big ball of mud. Who here has heard that term before? Anybody? All right. Cool. So it has a lot of drawbacks. We kind of alluded to some of them just now in passing, but just to call them out specifically, tight coupling between unrelated domains in your code base can happen very easily. And you can try to be disciplined about keeping a massive code base modular and try to maintain good abstractions, but when you have a single program running in a single process space, it's very easy and very tempting to start leaking across boundaries, to change a private to a public, to export one more method. And all of a sudden, things get much more intertwined than otherwise they might be. That leads to coordination among the teammates working on the code base becoming really tricky, because it requires a lot of careful planning to make sure that when you're writing features in parallel, you're not going to have all kinds of terrible merge conflicts, and that people aren't working on the same critical pieces of code at the same time. We already talked about massive deployments. It's a total headache. You have to plan for them carefully. You can end up spending lots of days doing manual QA to make sure that everything's working as intended. And that's necessary even for really small changes. You also end up with technological lock-in. So the stack that I was just discussing seems like it's a reasonably good fit for what we thought was our use case at the beginning. But once you have a million-plus line of code backend running on that, swapping any of those components out quickly becomes a pretty thorny exercise. It's not that it can't be done, but it's much more expensive to experiment with new things that you think might be a better fit for a particular use case. And as I've already mentioned, this creates a really steep learning curve for new developers on your project. So what can we do about this? Well, as you may have guessed, if you were paying attention during the title slide, we can adopt microservice architecture. So to answer that question that we started things off by asking, microservices are small, independently deployable, tightly scoped services that handle a single, well-defined business capability. These microservices work together in concert to service requests to the system as a whole, using standard small group of developers in a sprint or two, so in a matter of weeks, hopefully. So that's pretty small. So what does this look like? With microservices in mind, let's take a look at the previous situation. So remember, we had this massive application running as our backend that powered all of our APIs and handled a lot of other considerations as well. So with microservices, we can break all of these different capabilities into discrete business domains and create individual applications that power each one of those. So for example, user management can be called out as a discrete capability. Dog inventory can be its own thing. Reporting and creating business analytics can be its own subsystem that's maybe optimized for that kind of processing that needs to happen for deep analytics. Notifications, it's pretty easy to see why there would be advantages to having a platform agnostic means of sending a notification and encapsulating all of that code in some other platform. And walk scheduling, which is, I'm sure is going to be a pretty hot spot as far as very particular fine-grained business. Bring a new developer on, you can put them on the walk scheduling service. They don't have to know how everything in your system works to actually be productive and start contributing value quickly. You get smaller and faster deployments because you're deploying smaller applications that are more granular and have smaller contracts to uphold. So as long as you have some reasonably good testing in place to make sure that those contracts across service boundaries aren't broken, you can deploy with a great deal of confidence and pretty quickly. Means that because we have lots of independent applications, we can build each application using whatever bespoke set of tech tools we'd like to for the purpose at hand. So if we want to adopt like Elasticsearch, for example, for one particular corner of the application, for one service, we can do that without touching anything else and rest easy, knowing that it's only going to really be visible to that one part of our application. We now have a bunch of different services that are working in tandem to support a single request to the system as a whole. These services need to be built in a way that is more inherently fault tolerant. Now you're making requests over the network, and all of these requests can fail at any particular point in time. So I don't mean to say that if you adopt microservices, you're automatically going to have a resilient system, but designing microservices requires being very much thinking in a failure-focused kind of mindset. And taking that approach more broadly to application design is going to result in an anti-fragile, more resilient system. And ultimately, all of these come together to confer the major advantage of microservices kind of across the board, which is that of greater autonomy and less coupling between teams that are working on the same project. And Martin Fowler has written at length about these advantages and some of the trade-offs. So if you're interested in learning more about any one of these, I would definitely check this blog post out. So, sounds fantastic, right? Let's do it. This is the answer to all of our prayers, solution to all of our problems, all of our hopes and dreams. Maybe not. This is computer science, and if you've been doing this for a little while, you know that there are always trade-offs, right? Time versus space. There's no such thing as a free lunch. Whatever you get in one domain, you're likely to pay for in another. And this is absolutely as relevant to the decision to adopt microservice architecture as to anything else. And we're going to learn more about that momentarily, but many of the advantages that I talked about come with their own downsides as well. And it turns out there were actually a lot of luxuries to living in a monolithic world that we may not have even realized that we were enjoying while we were living there. So with that in mind, let's take a look at some of the common stumbling blocks that organizations encounter when they make the momentous decision to venture down this microservices path. Okay, the first pitfall is infrastructural complexity. This is a really big one. In the monolithic world, we had essentially a fairly simple set of servers we needed to run and maintain. We had some web servers that were running Node and Express. We had maybe a couple databases, like a master-slave or something like that. We had Redis for caching, maybe it was a cluster, and maybe we had a couple servers running Kafka as well. But unless we were dealing with incredibly massive amounts of scale, this is probably not an overwhelming number of servers. Like, you could probably actually physically manage these servers if you wanted to. But it might be feasible, and I certainly went places where that was the case. Now in this new world of microservices, we have all of these services that each comes with their own attendant infrastructural complexity. So it's not unreasonable to think that we might actually have hundreds or potentially even thousands of servers that we need to run to actually support our new microservice architecture across all of the different services we're running and also across all of the different environments. So what do we do about that? Well, the answer is really one word, and that is DevOps. But we want to expand upon that a little bit here. Ultimately, this is a matter of automating as much of our infrastructural complexity as we possibly can. So keeping our infrastructure as code, spinning things up, tearing things down, all using automated processes. And there's a couple of tools that can really help out with managing this overhead. So one of the first things you want is some sort of automated task runner for building out a continuous integration and continuous delivery pipeline. So Jenkins is a very popular solution for this. It's kind of an old standby. It may be the grandfather in the field. Also things like Circle CI, Travis CI that could potentially be leveraged to accomplish the same sorts of goals. But really any kind of framework for automatically running these tasks is going to be necessary here to do what we're trying to do. Once you have some sort of CI/CD pipeline set up, you need a cloud infrastructure provider that exposes APIs for managing infrastructure the way we're trying to. So AWS is clearly a pretty obvious choice here. There are other platforms as well that all building applications and deploying them, which is generally accepted as a best practice. So in this case, you build a Docker image that is the same between dev, QA, staging, and production, and you configure it differently by exposing different environment variables to it across each of those environments for things like application secrets and log level and things like that. So once you're using something like Docker to containerize your services, a tool like Kubernetes is a no-brainer for actually managing them in deployed environments. There's a lot of great facilities that Kubernetes offers, including the ability to deploy your containers into different namespaces. So, for example, you can have a single Kubernetes cluster, which consists of several different logical environments. So you can have, a QA, a unit testing, and an integration testing environment that are all running on the same Kubernetes cluster. There's a lot of other headaches that typically come with microservices that Kubernetes makes much more manageable. So things like service discovery. So if I have microservice A that's going to need to make some requests of microservice B, how does it know what IP address to use for that? How does it ensure that if there's multiple instances of service B, those requests are load balanced? So Kubernetes comes with a lot of nice things for dealing with this right out of the box. Also handles things like health check monitoring and actually making sure that you have the number of instances fielding requests that you want to, and can help ease the pain of dealing with cross-cutting concerns. So things like system resource utilization and logging can be pretty easily gathered using Kubernetes or sidecars and then shipped off to some central point for analysis, like an elk stack or something like that. And I should also mention that Capital One recently acquired Critical Stack. So I'm not sure if any of you have heard of this company, but Critical Stack is a company that offers container orchestration as a service. So essentially, this is a Kubernetes-compatible API that's offered as a service and is based on Kubernetes. It comes with much greater security protections out of the box. So it has some fairly advanced network packet filtering and things like that wrapped around the Kubernetes networking infrastructure to create a more secure environment. Capital One's obviously interested in that because we deal with a lot of pretty sensitive data, but it's a public platform as well. So it's definitely worth taking a look if you're curious about the containerization orchestration options that are out there. Okay. So another common pitfall that organizations tend to run into when they're adopting microservices the answer here is to adopt some sort of service scaffolding or templating tool. So this particular project is something called Node Bootstrap. It was put together by the senior director on my current team. And effectively, it's a tool for quickly generating microservice-ready this is that I know I was just talking about technological heterogeneity, and how that's like one of the great things about microservices, right? You can do whatever you want, using whatever language you want, with whatever supporting services you want. And this seems like we're moving back to standardization. So it might seem like those are kind of incompatible ideas. And the answer is like they're not really, because while you can definitely leverage the freedom to experiment with whatever you want when adopting microservices, in practice, you probably don't want to have 20 services that are written in 20 different languages using 20 different tech stacks. You're going to have a couple of pretty well-worn paths for building services. And you want to make building new services that don't have a lot of technological surprises baked in as easy and as streamlined as possible. And that's where these scaffolding tools come into play. If you need to try something new, something crazy, then by all means go for it and go off the beaten path. But in functional language, maybe a high-performance language, and you build templates or scaffolds for each of those so that kind of keep everybody happy, or at least equally miserable, depending on how you do things. All right, so another problem that companies frequently run into when they're starting down the microservice adoption path is that of lockstep deployments. So in this picture, none of these dogs can get anywhere because they're all tethered together in these horrible knots on these leashes. And like, it's not clear what the relationship is and where they could move, given this current dog topology, if you will. So what do we mean when we're talking about lockstep deployments? Basically, we're talking about any situation where you need to deploy multiple services at the same time to maintain some sort of functioning system. So to illustrate, imagine that we have an API client that is making a request to some service, service 1. And that service 1 is depending then on some downstream service, service 2, in order to fulfill that request. Now imagine there's a new feature we need to build that is going to get built into service 2 that service 1 needs to take care of. It needs to incorporate as well. So it might seem on the face of it that we need to deploy both service 1 and service 2 at the same time in order to not break things. Another scenario that's pretty common is that you have some service, let's call it service A, that's using a capability inside service B. That capability, however, is actually going to move from service B to service C, because it turns out we got the boundary wrong when we were doing our initial decomposition of the problem space. So the naive solution here is to do your rewrite of service A, which uses service C instead of service B, and move the service from service B into service C, and then deploy all three at once. This is a terrible idea, because first of all, you're increasing the size of your delta for each deployment. So if something goes wrong during the deployment, you don't know whether it was caused by a problem with service A, service B, or service C. And it also makes rollback a lot more complicated, because particularly if you're doing any sort of canary or blue-green deployment, rolling back all three of these at the same time, or even deploying them at the same time, initially for that matter, is not necessarily something you can easily do. So how do you prevent having to do this kind of thing? Well, you want to remove the leash. And there's really two primary means of doing this. The first and the best way of addressing lockstep deployment is to eliminate it entirely by making sure that you actually get your service boundaries right and keeping your services as autonomous as possible. The changes in one service don't require changes in another service for things to actually work as intended. And we haven't talked at all about actually decomposing problem space into microservice domains yet, but there's a couple of pretty well-known techniques for doing this. One is called domain-driven design. Has anybody here heard of that or heard anything about it? All right, cool. So in domain-driven design, typically what you do is you work with an expert in domain-driven design. You hire them at large cost, both in dollars and time, to come to your company and analyze your business space and work with all your business people and ultimately come down with some report they've generated that sort of, from a very top-down way, says, this is your business, and these are each of the domains that you've identified. And typically those mirror pretty closely real-world entities. So if we kind of run with this dog pool thing, there's a very good chance you would actually have a dog's bounded context coming from that. So that's domain-driven design. There's another approach, which is much newer, and it's called event storming. Has anybody heard of this? Cool. All right. Don't usually get much hands for that one, so that's neat.
Oh, I was looking on D-Zone yesterday.
Oh, okay. Yeah, that makes sense. So event storming was actually invented just a couple of years ago by a guy named Alberto Brandolini. And event storming is the very low-touch, agile response to domain-driven design. The way event storming works is that you get everybody on your project team, developers, design folks, product, project, UX, everybody, in a big conference room, kind of like this one. And you supply them with a potentially limitless number of Post-it notes and have them capture all the different events that can transpire during a user's interaction with your platform. So this is a very bottom-up approach, because you start by identifying all the events. User logs in, user registers dog, whatever. And then from those events, you put together a cogent narrative that explains exactly how a user progresses from one stage to the next. Once you have that, you can start to derive the existence of these higher-order entities in your system. So things like commands, or read models, or aggregates. And these aggregates ultimately become the bounded contexts that serve as the basis for your microservice design. So it's a really fun exercise. It only takes hours as opposed to months that can be spent on domain-driven design. And while it doesn't always yield exactly the same solution, it can be pretty close. And it's much less expensive to do so.
How is that different from agile use cases or use stories?
User stories?
Yeah.
So user stories are typically like a one-sentence description of a particular user experience with something. So like as a user, I want to register my dog so I can later schedule walks for it and that kind of thing. This ultimately gets to that same sort of user-focused thinking, but it does so by capturing domain events in the system. And it really, it requires everybody to think very critically about all the technical details of how that story is fulfilled. So one problem that I've seen in the past with just using the user story approach is that stories are underspecified. They don't actually capture all the details that are required to make the thing work the way the product owner thinks that they should. If you have an event storming session, that might be the starting point. Like as a user, I want to register my dog so I can do whatever. But that ultimately gets to a lot more detail.
Do you assume that you already have a system that you watch the interaction of users here?
So that's a really interesting question. I've facilitated a number of different event storming sessions, both for users that were building a system from scratch and for users that had an existing system. And what I found is that in general, it's helpful no matter what, but it can be more helpful if you don't have an existing system. And the reason for that is that if you have an existing system, you have existing biases as to what the service boundaries are. So there's a little bit of a natural inclination to think top-down instead of thinking bottom-up, which is really what event storming is supposed to encourage you to do.
Okay. Well, I was actually wrong. The ones that I read about were event streaming and event sourcing.
Those are very important and different topics, yeah. Those
the
are
architectural approach.
Those are architectural considerations to how you actually implement asynchronous microservices. But they're less to do with finding bounded contexts.
Okay.
Yeah.
But inherently, your boundaries are already defined because you've got requirements. You've got something that says that we need this thing to do this.
Right.
And therefore, encapsulating the scope of what it actually has to do.
Yes, absolutely. So at the top of any event storming session, you need to define what is in scope and what is out of scope for the project as a whole. But ultimately, you're trying to dive in and find out where the individual sort of subscopes lie, the different bounded contexts inside that. So even with event storming, even with domain-driven design, you're going to find situations where you do need to deploy things at the same time, or you think you do, because there are dependencies between services where you need to have a change in one service to support a change in another service. And the solution there is just to reason through your order of dependencies and start with the most downstream dependency first. So if we go back to that previous slide that I had where service 1 relies on a new capability in service 2, deploy a new version of service 2 with that capability and leave it unused. And then just deploy the new version of service 1 once that's in place. Or the other example where a capability was moving from service B to service C. Deploy the new version of service C that has that capability. Then deploy the new version of service A that uses service C instead of service B. And this feels kind of weird to us as developers because there's one thing we've been told since we started coding. It's, don't repeat yourself. Dry everything out. Having the same logic captured in more than one place is an anti-pattern, and we have to do everything we can to avoid that ever happening because there's going to be drift and it's going to be terrible. But one of the dirty little secrets of microservices is that it's way better to repeat yourself than it is to have really tight coupling between your services. And if you dry things out too aggressively in a microservice world, that's what's going to happen. So ultimately, this is about finding good boundaries and then thinking carefully about releases. Yeah?
If you do that approach, that means you're sort of having like multiple functionality in service. Do you eventually remove that more functionality? Or?
Yeah, absolutely. So that's I've heard that referred to as expand contract.
Yeah.
So if you have, for example, a service C and service B example. So service C expands with a new capability, and then once we're sure that things are working correctly, we've deployed service A to use service C instead of service B. We remove the old capability from service B. So that's with respect to that particular example. There may be other cases where you actually do want to have duplicated code without any sort of foreseen endpoint, because otherwise you have too much coupling between your services. Yeah.
Is that same sort of concept?
Yeah, sure. If you want to sort of load balance between services B and C and see how users respond to requests coming to each one, yeah, absolutely you can do that. And there's different mechanisms you can leverage for doing so, whether it's like at the Route 53 level in AWS or inside Kubernetes if you're doing some sort of load balancing there at the service discovery level. Okay, another pitfall, internal versus external. What do I mean by this? This guy doesn't know whether he wants to be inside or outside. And this is a problem in microservices too. Because so far, we've talked about microservices as each handling some sort of core business domain or capability, but we haven't really discussed the interaction between those services and the outside world. So one possible approach might be to look at the services that you've developed and say, okay, like dog walking is a useful thing for internal services to call, but I also think I want to expose these endpoints to the outside world because there's some pretty meaty functionality here that developers outside of my company are going to want to take advantage of, or the clients will want to take advantage of. That can be okay to start with, but it quickly gets unmaintainable because imagine that the requirements change between your public API clients and your internal microservice clients. What do you do then? Does your dog walking service now need to like sniff the API key or the client ID or something of the thing making the request and then formulate a different response? Like that could get really ugly really fast. But fortunately, there's a good and pretty well accepted pattern for handling this kind of complexity as well. The answer here is to establish a layer of services that interface with public clients of your API and have those public-facing services orchestrate calls against your internal microservices to fulfill whatever request needs to be fulfilled. And this kind of creates a public API layer for you. This has a lot of very nice side effects. It lets you completely tailor the response of every one of your public APIs to the client that's using that. So you can have a very well-defined contract on a per-client basis with a particular service. Folks here familiar with outage-oriented programming and patterns? Anybody? Daniel 4 type stuff? So there's a pattern called the facade pattern, where basically you have some class that exposes functionality, and you wrap that class in another class. And all that second class does is pick how it wants to expose the contract of that functionality. And that's very similar to what we're doing here. We're taking all of these capabilities that are implemented in terms of internal microservices, and we're picking on a per-client basis exactly how we want those services to be exposed and what the request and response shape should be. So all these public services are really doing is making downstream calls, and maybe they're doing some early validation to avoid unnecessary load on your network, and they're potentially reformatting the responses to whatever your API spec for that particular client dictates. But there's not much more to it than that, and it can solve a whole wealth of problems. This is also not a new pattern by any stretch. So it's gone by a lot of different names over the years. Phil Calzado, who is at SoundCloud, called this the backends for front ends approach. And hopefully that makes a little bit of sense. These are all front ends, and these are per front end backends. So you have one backend per front end. Dan Jacobson, who used to be at NPR and is now at Netflix, referred to these two different layers by two different names. He called this the experience API. The idea is that that actually drives the user experience. And the backend microservices he referred to as the ephemeral APIs. That nicely captures this sort of disposable, recyclable, experimenting-oriented approach to handling microservices. And Etsy also has a name for this. They call the backend services the component services, and this they call composite services. So again, the idea here is that each of the composite services assembles various components and ships them off to the client in a format that the client is expecting. So far, I've really been talking about technical problems and technical solutions, but shifting to microservices architecture requires a huge cultural change in your organization, and potentially its way of doing things. And that really affects the people in your organization. And this shift, this kind of cultural shift, can be a really challenging one to make, especially for organizations that have been doing things monolithically for a long period of time. There's a lot of advice that we could go into about dealing with this kind of organizational shift, but it could easily fill several more talks. So I'm not going to go into it in too much detail, but I really want to stress that the decision to adopt microservices is not something that a bunch of developers can just like go off and do in a room by themselves. Who here has heard of Conway's Law? Okay. Conway's Law is this principle from business organization. The output of an organization tends to reflect the org chart of that organization. So if you have a big monolithic org chart, you're probably going to have a big monolithic piece of software that's being created by the organization. If you have a bunch of little autonomous teams, you're more likely to have microservices. There's also something called reverse Conway's Law, which is basically hacking Conway's Law to kind of make sure that the output is what you want it to be. So we acknowledge that we want microservices, so let's actually make our org chart look like that. This is one of the considerations that you need to take into account if you're considering this kind of approach. And once you've decided with your non-technical folks that this is really what you want to do, you need to work really closely with them. This is an ongoing partnership. Understand the business domain, to do things like event storming, and to really make sure that you're finding the right boundaries for all of your different teams, for all of the different domains that you're handling as you make this transition. So just to recap what we've talked about so far, you want to mitigate infrastructural complexity by automating as much as possible, hoping that isn't too much of a surprise. You want to minimize the startup time for each of your new services by using some sort of scaffolding or template tool for generating new services quickly and easily. Avoid lockstep deployments by any means necessary. This can be solved a couple of different ways by trying to find the right boundaries between your services that gets you the highest degree of autonomy. And that will require revisiting that boundary from time to time. Like once you've generated your boundaries from an event storming session, you're not done. Your company's needs are going to change over time. You're going to have growth and shrinkage in each of your services. And you need to account for that in the way that your services are broken apart. So it's very common to have services grow over time and then get split up into two separate services that are now independently contributing capabilities that was previously being done by a single service. And you also want to create dedicated services for managing these requests that come from external clients. So this is the whole public API layer that we were just talking about. But that's not all. There's a lot more to consider when adopting microservice architecture. And again, we don't have time to go into all of it today. But if you're interested, these are a couple of great books that I'd recommend, and they each touch upon a different aspect of the transition to microservices and to microservice architecture. So Microservice Architecture by Irakli Nadarashvili, Ronnie Mitra, Matt McLarty, and Mike Amundsen is a great high-level sort of philosophical introduction to the way that microservice architecture tends to change organizations and to require a big shift in their way of thinking about approaching problems. Building Microservices by Sam Newman has tons of very tactical advice about solving thorny technical problems that do tend to crop up when you start down the microservices path. And Production-Ready Microservices by Susan Fowler is a collection of recommendations. It's basically a big checklist with a chapter devoted to each one that lets you know all the things you should be considering before actually considering one of your services to be production ready. So everything from resilience to logging to analytics and to service discovery and beyond. So highly recommend all three of these if you're interested in hearing more about any of these topics. So with that, thank you for listening and have fun on your microservices journey.
Thanks.
Thank you.
I'm not sure if I think I didn't address this, but how do you, let's say you have a monolith and you're trying to move that to microservices, maybe you're using like a strangulation pattern or something like that.
Yeah.
How do you, how I know it's hard to figure out, maybe you can use the event storming as we mentioned before, but let's say you have like a users kind of thing that a lot of the other services are going to depend on. Is that something you would like carve off into a separate service, or would it be like, I don't know, as I was thinking about this one application that we have, and I'm thinking about how to do this with this, there's certain things where it's like every service would depend on this service. And it seems weird to have that extra hop every single time, especially like I'm grabbing a widget, and that widget has a user, an owner, and a thing, the widget, a list of users that use a widget, or something like that. Each one of those being a different kind of call to a user service. So
you have to like hydrate each one of those users through some call to the user service.
Yeah.
Yeah, I mean, that's a fair point of consideration. There are technologies that can mitigate that network overhead, basically, because it sounds like you're concerned about performance more than anything else.
Yeah, or just, usability too as well for like, or frankly, I'm worried about the devs revolting and saying this is crazy.
Well, I mean, it's important to keep in mind the guiding principle here, and that is that we have problems that are caused by our code base being too big, like all these motivating problems that are driving us in the direction of microservices. So one mistake that organizations frequently make is they go with services that are way too granular to begin with. And they're actually ending up with even more coordination than they previously had, because now, like, not only are they having to coordinate when they do releases, they also have all the extra crap that accompanies microservices, all these different repos, all these branch models, all these pieces of infrastructure. So if you're not sure and you're just starting off, going a little bit more coarse-grained is usually a better way to do things. But with something like users, yeah, there's going to be hotspots. There will certainly be services that get a lot of attention. And you have to think carefully about caching between services. So what sort of staleness can you tolerate for user data? There are lots of libraries, like Hystrix, for example, is one that Netflix developed for the JVM, that is designed to deal with communication problems between microservices. So it implements things like circuit breaking. If your downstream service goes down, you don't want to keep hammering it, because that can cause all kinds of problems that will then take your whole system down potentially. You want to have some kind of exponential backoff that will let you wait for that service to be healthy again. So, and there's also things like gRPC, protocol buffers, and like ways of communicating more efficiently over the network if it does become a component of a lot of traffic.
So you took the one database and split it up into 5.
Yeah.
You're going to drive DBAs nuts if you've got 5 different schemas, or do you still keep the monolith database?
So you definitely have 5 different schemas. One anti-pattern in microservices is having any kind of shared mutable data store, like a database that is shared by a bunch of different services, because that can cause all kinds of really pathological and hard to diagnose bugs. You have services that you can't even necessarily like search across a code base for anymore, because these are in different repos, right? They're potentially using the same columns. You're in for a world of hurt. So you have to actually have totally separate schemas. You might actually have the same infrastructure underlying those. So one thing I have seen, for example, is like you have the same RDS cluster. It supports multiple schemas, and each of those is being used by a service. But that's more to mitigate the infrastructural overhead than it is to help preserve DBA sanity.
Well, basically, someone will come and say, I need now this to be exposed, and usually, okay, it's in this table. Now you're saying, basically, you have to repopulate that database and move, or duplicate that
So
across multiple areas so that they don't talk to each other.
well, or if you really need that piece of data, then that microservice needs to be changed to actually expose it to some particular data.
Right.
But you also need to be careful with that too, because then you kind of walk back into like the leaking information, and now all of a sudden we have a big ball of mud, but it's a big ball of distributed services mud, and that's terrible too. So you have to think pretty carefully about that. In transactions, it's kind of a little bit divergent, but that's also a problem in the microservice world. You need to be careful about transactions in the database sense when you're defining the microservice boundaries, because anything that's really must be a critical transaction, you probably want to keep it on a single microservice level so it can be enforced at the database level. Otherwise, you do end up with like sagas and other distributed system style transaction handling and resolution, which is very doable, but also increases complexity if not that. Yeah.
So how do you work in your services? What version in your services? Like you
Oh.
version in your services?
Don't version your services.
You just override.
Yeah, well, I mean, yes, I was
For example, you don't do that.
right. So what I mean, I was being a little bit glib, is that versioning APIs is a traditionally very painful thing to do. It's something that everybody has to do at some point or other, but the best thing to do is take a more evolutionary approach to API design. So make sure if you're designing an API from the get-go, maybe don't have it expose just a scalar value. Maybe have it expose JSON, so that you can add fields to it organically over time. And there are also ways of auditing the logs of your API clients to actually figure out who's using what fields, especially if you're using like GraphQL or some other.
There's a millions of services.
Yeah.
And you have to like figure out that.
Mm-hmm.
You got to make sure that the whole field of microservices
Yeah.
is one unit. So you got to make sure that
Well,
users.
I mean, you want to start with the roots of the tree. So you're adding capabilities in one place and then slowly percolating them up through the rest of the stack. You want to try to stay away from releasing 20 different new versions at once because, I mean, all hell might break loose.
And the other thing I think is like service discovery.
Yeah.
There's a lot of tools like Council and CD and
Yep.
stuff like that.
Absolutely.
So like the thing is there's some learning curve. For example, if you want Kubernetes,
Mhm.
you require the
Oh, yeah. No,
nobody wants to.
Kubernetes is fantastic, but getting it installed and set up,
Yeah.
especially if you work for a bank, is a very difficult thing to do.
Or the government.
Yeah, absolutely.
There's tools around that too, like Helm and those other things,
Mhm.
making this starting to be a little bit easier.
Yeah.
Getting Kubernetes installed, at least the day zero type thing, day 1 and 2 thing.
Well, it's only recently kind of become clear that Kubernetes is kind of going to be it, as
Yeah.
opposed to like Docker Swarm or Mesos or something. So I think there's more momentum around it.
To your point, that a lot of those topics are going to be talked about in a few weeks when we get that speaker.
I think it's easier to do it when it's in cloud because you don't have to rely on too many people.
Yeah.
But if it's on-prem, doing anything, any new installation, it takes a while.
Oh yeah.
Any kind of migration takes forever.
4700, I think there's a new cloud adoption initiative that they're running. I think some of the stuff that we're talking about there is going to go back to the on-prem version. Like I was explaining them, like, you guys want to go to the cloud, it still requires paper to get an IP address. Like that's broken. You fix that first. So they're starting to look at those sorts of things. And it's okay. Like groups like ours, since we started to come together and we're actually not single devs or team of small teams, we can actually push back on some of those things now and say, hey, like this Launchpad thing breaks API, right? And they're like, what? I never heard that before. I'm like, but all of us complain about it to each other. We complain about it to them.
That's the one point. What about security?
That's a really interesting topic, and it's also one that takes a lot of. I mean, yeah, there's all kinds of layers there. Security in general is something that you probably don't want to re-implement in every service. Like you want to have some sort of central gatekeeper. So that slide that I had with the public layer of APIs, like chances are pretty good that in front of that you have some sort of API gateway. That's handling all of your external traffic and making sure that your OAuth tokens are valid and all kinds of stuff like that. Then within services, you also have other security problems to solve. So JWTs are a nice way of solving that problem more generally. Then you have to get the certificate distribution law, which is also not a very fun thing to have to manage manually. So yeah, there's a lot to unpack.
So, very quickly back to the issue. So you may or may not be aware of TM is NASA's middle name. And so there's always some guy who's going to ask you about that. Someone whose job it is to do nothing but sort of ask stupid questions about your CM. So, given that, and given the dependencies that one might come across when you're developing, what's the best strategy for, sort of cleaning that wild for you?
To not drive the CM folks crazy, standardizing on one tool for configuration management is probably not a bad idea, especially if you're already doing something like that in Kubernetes anyway. Maybe you can use like HashiCorp's Vault to handle secrets management, or use secrets in Kubernetes or something. Kubernetes also has a notion called config maps built in, which are used to manage configuration of individual services in different contexts. So that may also help with things. Now, it sounds like configuration management is a whole other topic of conversation here at NASA. So I don't know if what I've said applies even in the slightest, but
well, no, I mean, right, it's something that you've got basically as long as these people can check off the box and say that they do good job, we're pretty happy.
Right.
Ultimately, at the end of the day, we're seeing some review from a bunch of people whose job is to go to exit. You have to go to justify.
Yeah, we deal with similar things at Capital One because banking is a pretty heavily regulated industry. So there's a lot of hoops to jump through, a lot of regulation, a lot of boxes to check. And I've been pretty impressed by how agnostic things generally are. So there's more a question of, have you done this? Are you managing your secrets securely? As opposed to, are you using this one tool that you always manage your secrets? So.
Getting those people on board early helps, right? And like Justin was mentioning, is sometimes they have a solution in their mind, but they're really getting to what the problem is, and then you can say, well, here's the problem. How do we solve that in this tool or this architecture that we have? Usually they're okay with it once you explain it to them. They're on board with it before, like, we throw it over the fence at the end and say, here it is. And they're like, well, this is not what we're expecting, and then there's problems.
And a lot of times, especially when I did this back in '74.
Yeah.
So now, the context of
and that goes back to Justin's people slide, right? You gotta go stroke the people's egos and buy them lunch, tell them how cool they are.
Especially from
Bring them up to date.
From day one, though, to your point, like, you want to do that early because you don't want any nasty surprises on the day before you're going to launch.
You have like a 2-minute version of the slide.
A 2-minute version?
That was a 2-minute version.
I mean, I would say read the books, understand the motivation behind microservices if this is something that you're passionate about introducing, and have conversations with non-technical people that you work with on a daily basis, and try to socialize the ideas a little bit more. And then elevate the conversation as needed to whatever the kind of natural point is for scoping your microservice universe. Right? It may need to be an organization-wide decision. It may not be. It may be the sort of thing that you can do in one particular part of the organization, depending upon how siloed things tend to be. Yeah.
I guess so. The whole premise of microservices, it was motivated as like, a system that's evolving or expected to evolve. So you want to build in the capability of sort of to keep it to its conclusion. Or if you want to say, okay, there's a system that is built with a microservices infrastructure, we don't expect it to evolve. Is there then a process to sort of start consolidating that into a model? Does that even make sense?
That's an interesting question. I'm trying to think about the motivating factors for actually consolidating. I guess one might be like resource usage. If you're running too many instances or something, yeah, performance could be another.
Is there does that ever happen?
Honestly, that's not something I've given a whole lot of thought to. Usually the problem is the service is too big, let's break it down. You might consolidate individual services, and you can sort of like have like a reverse strangle pattern, I guess.
I've heard about that happening. Like you'll get the boundaries wrong, something like that, and you realize there's no need for that boundary because every time you change this one, this other one changes with it. It's like, well, why are they two separate things? I think Kane also they like he's here right now. At least in our group, I think they did that way. Both now, like microservices, started putting some of them back together. I think the term micro kind of implies this really small thing, but it's context-based, right?
Right.
Like, okay, you start off like, you got all these little things, and you realize, like, we have a team of 5 people, and we have like 10 services.
Yeah, but the same
Right.
thing happened in OO. You know, we broke down things into smaller objects, and then we had all these files, and it's like, why do we need 100 files?
Right. Yeah. Yeah. So let the solution space fit the problem, I guess.
A lot of it seems like it's very boundary oriented.
Mm-hmm.
Do you have any rules of thumbs for figuring out where to draw the boundaries? What are the good sort of, what are the not all this that you have?
So, yeah. That slide that I had back up with the boundaries here. So I think of these, notifications is kind of a slam dunk for its own microservice. That kind of has microservice written all over it because there's a very well-defined contract there. You know, I mean, it's, you use like SNS or something, it's probably basically a notification microservice. Reporting can be kind of a weird one because it fits into like sort of cross-cutting concerns bucket where like if you have a reporting microservice, it's pretty easy to think how all of your other services could be constantly hitting that reporting service by saying, hey, notice that this thing happened. Notice that this other thing happened, right? Like you could end up with a lot of coupling.
I find a lot of annoying with security is now you have one server. It's supposed to be isolated, but it really isn't because everyone else helps with it. So it's not isolated at all.
Mm-hmm. So a good solution to that, and I didn't depict it here because it's a little bit more like an advanced topic in microservice architecture, is using like a more asynchronous kind of approach. So for example, if you have a append-only log of all the events in your system that's being stored in Kafka, say, then you can have different services that are storing these events. You have whatever your online transaction processing or your analytics or reporting service is consuming those events and creating whatever materialized view of that data is necessary for shareholders to actually understand what's going on inside the service. So it removes the coupling by creating more of like a pub-sub model of storing this stuff. Security is often something you don't want to re-implement all over the place, as we were discussing earlier. So you want to have a single place where you're making sure that your requests are being secured from like a user management standpoint. So, SSO token is being validated or something like that. Probably don't want to scatter that logic everywhere. So I don't know. Does that give you some notion of boundaries?
Usually, I'm more familiar with bounding, the bounding things in the process from security perspective. Like Jim mentioned, it's the same thing.
Yeah. So
you got to figure out what you want together.
So, I mean, the event storing model for figuring that out is, as I mentioned, you generate all these events of things that happen inside your system. And if an event is just a statement of an action that's described in the past tense. So, dog walk schedule, for example, would be an example of an event. Every event has to have some sort of source. So that source could be a command. And there's always an entity that sits between a command and an event. So there's going to be this thing called an aggregate, which is a terrible term. But an aggregate takes in commands. Those could be the result of like a user interface button being pushed, for example, and then generates one or more events on that basis. So one of the reasons you might end up with a walk scheduling bounded context here is because you have this walk scheduled event that's being triggered by a schedule my walk command. And there's something that's processing, that's managing that command and turning it into some domain event. So that's kind of one way to think about this stuff.
Question online.
Yeah.
Says there's always complexity. Why is it better to have complexity in configuration deploying a bajillion microservices rather than the code packaging you build a bunch of classes, languages, etc. together? You can have exactly the same discussion about boundaries in microservices and discuss the boundaries between classes and libraries.
Yeah, so that's a great question. One is that eventually your program's not going to scale. if you are trying to do everything on one single process space. Another is that it is too easy to cheat if you have boundaries that are defined in class definitions. I kind of alluded to that earlier. You can always change visibility. It's a little bit harder to go to some other team and say, hey, I need you to expose this field for me. And that imposes overhead, but it also imposes discipline. And discipline is kind of what got us in here in the first place. Yeah.
You picked Node.js for this. Have you found certain languages really good for microservices and some that aren't?
It's really...
I've seen it in Java. I've seen it in Python.
It depends on the problem you're trying to solve with that particular service. You know, I mean, some like JavaScript. If you like writing in Node.js, then it can be a very pleasant language to develop microservices in. But it's not so much because it's great for microservices as because it's something that you're comfortable with. There's good web framework support for it. It's good at handling web requests. It's good at like non-blocking stuff. So that kind of makes it well suited for it. But there's other situations where you pick other things because you have more computationally intensive processing. Like, write your web server in C for your crypto microservice or whatever it happens to be.
Well, I think this is probably the last question given the time. Another one from Stephen online. First one was from Christine. Second one from Stephen. Telemetry request level performance monitoring best practices are there. I think you talked about it a little bit.
Yeah, there are plenty of tools for monitoring microservice performance and to sort of see where things are going south. Like if there's any slow points in handling all the requests that are associated with a single top-level request. So I'm trying to remember. There's one that was developed at Twitter. What's that?
There's one.
Prometheus, yeah, Prometheus for sure. Yeah, there are definitely tools for monitoring this. And one thing that's often done, too, to kind of get to the management of complexity of these requests is to assign correlation IDs. So you have one top-level request. You give it one UUID or something that says, everywhere that this ID appears in the system is part of the same logical request. And there's a tool that Twitter developed called Zipkin for automating this and building it into microservices architecture. But it helps you figure out what's going on where and why.
I don't know what it is, but something where you put in each of the side.
Okay.
Yeah, and it's like that'll handle that for you. Like you really routing the traffic through and then also tracking the requests as it goes to the different parts of the microservices. So you don't have to build that actually into your actual code base. You can add it in later on. Which I thought was pretty cool.
Yeah.
We have the same thing where a request comes in, create a GUID, and then we have to remember every time we pass an event or something like that, to make sure that GUID's in that event, and then somewhere else, make sure you take that GUID out of the event, put it into like the area where the rest of the code is going to know it's there. Yep. And it's not a hard thing to do, but it just requires a lot of forethought.
It's easy to forget too.
Yeah, it's easy to forget. But that method that they have where it's like you can just bolt it on afterwards, and it's like now you have distributed tracing, you know what I mean? Like for free almost. I thought that was pretty cool. Yeah, there's a lot of capabilities that can leverage at that level. Yeah, it makes sense to have out of the box. Cool. All right. Well, thank you, everybody. Really appreciate it. All right. Yeah. Thank you. All right. So next week, Cold Fusion. Even if you're not a Cold Fusion developer, I think it will still be a good.
Is it next week or next time?
I'm sorry. Next time. You guys know me. I don't know what's going on. Next time. Please, someone else try to present. I know we have a lot of smart people here. It makes my job a lot easier. Yeah, say, hey, we'll do that.
Justin, were you down at NPR in Silver Spring